So what are these? They're actually a really very efficient form of one of these. Dew shield, dew strap thing that we've seen for such a long time. The reason I made them was because I realised just how inefficient the traditional dew strap is. It uses a lot of energy and it loses a lot of energy when really the energy has to get to the glass. And if it's out on the dew shield, a lot of it gets wasted, and we can look into that. But this here is probably the world's first, as far as I can tell, internal dew heater. So this one I've made for the RedCat 51 Mark 1. The reason I did the Mark 1 is because when I started designing this, that was the model, and there's so many of these wonderful telescopes out there that I just decided to keep doing it. Yes, I am working on one for the RedCat Mark 2 and probably the Mark 3, because where the dew shield is, they actually look the same, but that's yet to be proven on the Mark 3. How do you put it on? Easy. We unscrew the dew shield. Place the heater type of your choice over the end. Pass your finger around, making sure that the edge of the heater has popped over the side of the objective cell, and then let it drop down. And then you can just wind it forwards and it should pick up the thread. There we go. Sounds like it's got it. And then you just start winding. And you wind it back most of the way. It has some resistance, so you can actually lock it in any particular spot. The heater is pushing against the metal, as it should, to make a decent contact, so that gives it a little bit of tightness. And it's in. And then we screw back on. If we can pick up the thread, there it is. The dew shield, and it's done. I like to wind it back a half a turn just to separate these two bits of metal. It helps reduce the amount of heat that gets lost from this unit to that unit. And the same thing on this end, from there to there. There's no need to have it up tight against its stop. That small amount of separation will reduce the amount of heat loss that goes between the two of them. So now it's on. It comes in 3 different connection styles. USB, 2.1mm plug socket, and the one that you're currently seeing on the unit, the RCA. So the RCA, I think, suits the Dew Zapper, the Pegasus units. The 2.1 is suitable for the Azair. And it comes in a range of colors, which is what I accidentally just showed you because I was going to wait, but damn it, who cares? It comes in black too. So you've got black and red. If somebody wants enough of a particular color, I can arrange for it to be anodized in some other color, but this would suit the black and white cat, and it would suit the space cat. And well, the red cat will go with the red one. The other interesting point about this is that the heater can be removed. You can see there. It's a consumable effectively. So whereas with this heater, if anything went wrong with it, you just have to throw the whole thing out, plug, cable, strap, everything. With this one, the metal component should last indefinitely, but if you need to replace the heater, it's a relatively inexpensive consumable, so that can be changed. It also is possible to get different wattage ratings. The USB is currently, I'm offering this in a 5 volt 1 watt system, and that still seems to be enough for most circumstances. Now, I don't live in a freezing cold part of the world, but down to a couple of degrees Celsius, this unit has still kept the dew at bay. The USB is 5 volts at 1 watt. The 2.1 and RCA are 12 volts and 2 watts. So that gives you plenty of headroom for colder places. And then I'd recommend that you could probably set the pulse width modulation on your controller to something like 50%, because 50% or effectively 1 watt, which is what I've got in the USB, seems to do a great job. So how efficient is it? And you can see in this picture that I've got taken with an infrared camera, just how much heat is being put into the dew shield. If you can see heat in an infrared image, then it's also emitting heat. And if you're putting it into the dew shield, you're losing a massive amount of heat out to space when actually that heat needs to get to the glass. So this design where it pushes up against the glass, that is about as efficient as you can get. And so these ones I find can get 60 or 70% reduction in energy consumption for a given set point in temperature.